Hello guys, it's nice to be back again, and so we're gonna carry on with part 2 of the May 2024 MYP E-Assessment maths paper. So in my previous video we went up to question 5, and now we're going to be looking at questions 6, 7, and 8 in this video. Now, so question 6 was a very interesting question. It was basically comparing the Gregorian measure of time against the metric time, and generally there will be a lot of comparisons that's going to be made between these two forms of time. So generally the first question was basically finding the missing times on the diagram, and we're supposed to find out what is the time for the metric 10-hour day in part 1 and in part 2. But do bear in mind, in this question, what is really important is basically this piece of information about metric time. And we know that metric time uses 10 hours for one day instead of 24 hours, and each metric hour is basically the equivalence of 100 minutes, and each metric minute has 100 seconds. So that's the big difference between the metric time and the Gregorian time as well. So we're going to be looking at how we could find the time that is taken for the metric 10-hour day. So let's look at part 1. So when we look at between 12 midnight and 5 o'clock in the morning for the metric 10 hours days, but do bear in mind, because every metric hour is worth 100 minutes. So if we're looking at between the midpoint between 12 midnight and 5 in the morning, so technically if we look at the Gregorian, it would be like 2:30 in the wee hours of the morning. But in this case, you gotta bear in mind, because 1 hour is basically 100 minutes, so half of 100 minutes would be 50 minutes. So instead of actually having 2:30, we're going to be written as 2:50, right? Because half of 100 is basically 50. And similarly for part 2, if we want to find the time, it will also be 7:50. Okay, and in part 3 we're just finding the Gregorian 24-hour day, which is the same thing that we go through in terms of an hour having a day being 24 hours, and an hour is 60 minutes long. So in part 3 we have 6 in the morning here, and you have like 6 in the evening here. So of course the in-between, or the average between these two times, would just simply be 12 noon. So we're going to put 12:00. Alright, so yeah, I think this is generally quite easy for 2 marks. And in question 6b, we're looking at finding the number of Gregorian hours and minutes in 1 metric hour. So what we need to do for this particular question is to look at for 1 metric. So I'm just going to go back to this piece of information, okay? So we know that for metric time, it uses 10 hours for one day. So just gonna write this here. So I'm gonna put for metric, 1 day is equal to 10 hours. And for Gregorian, we know that 1 day is 24 hours. So the question is basically asking, in 1 metric hour, how many Gregorian hours and minutes will you have? And since we know that for 1 metric day, you're going to get 10 hours. So for 1 metric hour, what you're going to be having is you're going to take 24 divided by 10. That's going to give me 2.4 Gregorian hours and minutes. So we just need to convert 0.4 hours into minutes. So in this case, we're going to write this as 2 hours, and of course, since we're converting it into the Gregorian system, which is 0.4, so we're going to multiply this by 60, since that we know that 1 hour is basically 60 minutes in the Gregorian system. So 0.4 times 60, that's going to give me 24 minutes. So I'm going to put 2 hours and 24 minutes for this little box here. Okay, so generally quite easy as well for 2 marks. And so the following question is just about trying to convert from minutes into seconds. So which is basically 1 minute is the equivalence of 100 seconds, and they basically show you an example of how you could convert 528,030 metric seconds is basically the equivalence of 5 days, 2 hours, 80 minutes, and 30 seconds. So the following question is really just simply converting from a metric time into the metric seconds. So we do know that a minute is 100 seconds. So if we have 90 minutes here, so we know that to convert that into metric seconds, we're going to take 90 times 100, which is basically 9,000. But what we are expected to do for this question is to convert 9,000 into standard form, or basically what some of you may know this as scientific notation. So we can actually write this as 9 times 10 to the power of 3. And the next part, if we convert 2 hours and 40 minutes, generally what we want to do is to convert 2 hours into seconds and to convert 40 minutes into seconds. Now we do know that in metric time, an hour is basically the equivalence of so again, I'm going to show you where you should be getting this information if you're troubled. Is that each metric hour is 100 minutes. Okay, so we're going to make use of that. So 2 hours is the equivalence of 200 minutes, and you have 40 minutes here, so 240 minutes in total. So and we have to convert 240 minutes into seconds, so we have to convert this by multiplying this by 100. So you're gonna get 240 times 100, which gives me 240,000. So that should give me basically 2.4 times 10 to the power of 5. Oops, sorry. I think I wrote this wrong. 1, 2. Oh, I think I wrote an extra 0, so it should just be 24,000. So let me just erase this. This should technically be a 4. Okay. So it's just basically converting hours and minutes into seconds. Alright, then we just move on to the next question, where is the time to run 10 kilometers. You have the metric seconds, so 5.3 times 10 to the power 3. That's the equivalence of having 5.3, moving the decimal point 3 to the right. So you're going to get 5,300 seconds. And and we know that 5,300 seconds would be the equivalence of dividing this by 100. So that should give me 53 minutes for the metric time. Again, we're going to be using this conversion here. And finally, which is converting 4 days, 2 hours, and 5 minutes. So we just have to convert each component into seconds. Okay, but before we do that, we can obviously find out that in a metric time, 1 day is the equivalence of 10 hours, which is a very short time. So 4 days is the equivalence of 4 times 10 hours, which is 40 hours. Then we have 2 hours here, and so if we add 40 hours to 2 hours, we're gonna get 42 hours here. Okay, but not forgetting that 1 hour actually has 100 minutes. Okay, so 1 hour is equal to 100 minutes. So if you have 42 hours, we're gonna take 42 times 100. That's gonna be 4,200, and not forgetting we're gonna add the 5 minutes here, so we're gonna have 4,205 minutes. Now, and not forgetting, we have to convert this into seconds. So 1 minute is basically the same thing as 100 seconds. So 4,205 minutes would be the same thing as multiplying this by 100. So that should give me 4,20500. So it's 420,500 seconds. So again, we're going to convert this into scientific notation. So it's going to be 4.205 times 10 to the power. So if you put the decimal point and we just count 1, 2, 3, 4, 5. So it's going to be times 10 to the power of 5. So I think this question is reasonable. It's just basically conversion from minutes to seconds, or maybe hours to seconds, or days to seconds, all in the metric time. Okay, and basically writing that in standard form. So I think this question is reasonable. Moving on to question 60. This is again, this is all about simultaneous equations, and so they basically told you the definition of some of the variables that's being used here. Please do have a look, but just to really simply looking at the question, at least for the first part, is to convert the equations into words. So it says, what is s plus d equal to 160? What does this actually mean in words? So if we are looking at the number of single sessions, which is represented by s, and the number of double lessons for the maths department, that is represented by d. So if you add s plus d, obviously we're looking at simply the total number of lessons, right? I mean, we're looking at both combining both the single and the, so I can say that these is basically virtually the total number of lessons. And if we have 20s plus 40d equal to 4,000, we're supposed to write that in terms of words. So, and single sessions basically is 20 metric minutes long, double sessions 40 metric minutes long, and when you add both of the time together is 4,000. So what we could say is that the total duration, sorry, this should be 160, and the total duration is just simply going to be 4,000 in this case. Or you could just simply write it, if you want to be more explicit, you could just say the duration of both the single and double lessons would be 4,000. I think that generally be accepted as well for this question. So it says, by solving simultaneous equations, find the value of s and d. So I think this one is really straightforward. So I'm just going to show you quickly how to do this. Then you have 20s plus 40d. That gives me 4,000. So I think using elimination might help the best. What I'm going to do with this equation is I'm going to multiply this maybe by 20. So I'm going to get something like that. And I have 20s to be the same. Let's just call this equation 1. I'm going to call this equation 2. I'll take equation 1, subtract equation 2. So I'm going to get 40d minus 20d equal to 4,000 minus 3,200. So that's 20D equal to 800. So D would just be 40. And we can easily find S by substituting it into this equation, which is 160 minus 40, which is 120. Okay, so and simultaneous questions are usually very common in the E-assessment. Okay, so let's look at the next question for 6F, which is simply just a mark, and the question is basically asking for showing that the rate of production is 2.987 milligrams per minute. So we need to go back to this again. It says that it takes 1 metric day to form 2.987 grams of copper sulfate crystal. So, and if we look at the units, which is the rate of production, we're looking at milligrams per minute now. So let's just do some conversion here, which is basically 1 gram is the equivalence of 1,000 milligrams here. Okay. So we know that 2.987 grams is basically the equivalence of taking 2.987 and you multiply this by 1,000, which gives me 2,907 milligrams. Okay. Now we also know that 1 metric day is the same thing as 10 hours, and we know that 1 hour basically has 100 minutes. Okay, so we're going to take 10 times 100. That's going to give me 1,000 minutes. So if I want to find milligrams per minute, I'm going to take 2,987 over 1,000. That should give me the rate of the production in this case, which would be 2.987 milligrams per minute, which obviously has been shown for this question here. Okay. All right. So let's move on to question 6G, and it says calculate the maximum number of grams that can be produced from 4 in the morning on day 1 to 4:90 on day 2. Okay, so watch out for this. So we do need to find out how much time is taken to be produced from that time to that particular time in day 2 in this case. So we need to find out how many hours and minutes, if possible, that started from 4 in the morning to 4:90 on day 2. So what we could do is, we do know that if it starts at 4 on day 1 to 4 in the next day, and we know that 1 metric day basically will give me 10 hours. So we do know that from 4 to this, that's obviously going to give me 10 hours for sure, because 1 metric day is basically 10 hours, right? Then not forgetting from this to this, we obviously look at 90 minutes, which is basically the equivalence of 10 hours and 90 minutes, which is the equivalence of 10.9 hours. Okay. Of course, you can convert all this into minutes if you want to. That is fine. But I'm just going to keep it in terms of hours. This is also the equivalence of simply 1,090 minutes. So either one should work in this case. Alright, so we're going to look at the next part, which says that calculate the maximum number of grams. So what we could do for the next part is okay, so let's go back to this question here. So remember, it takes 1 metric day to form 2.987 grams of copper sulfate crystal. Okay, and we do know that 1 metric day is basically the same thing as 1,000 minutes. So I'm just gonna write this. So 1 metric day is the equivalence of 1,000 minutes. Now, since we have 1,090 minutes, then I think it will make sense for us to take 1,090 divided by 1,000, and we're going to multiply this by 2.987, which is basically simply taking 1.09 times 2.987, and that should somewhat give me the equivalence of, because the question says give your answer to the nearest gram, so this would be approximately 3 grams for this one. Okay, so generally what I would like to summarize for this question is we need to find out the amount of time from 4 in the morning on day 1 to 4:90 in the morning on day 2. So we need to calculate how much time is taken from this duration in this case, and we found out that it's basically the same thing as 1,090 minutes, and we do know that 1 metric day is the equivalence of 10 hours, which could also be converted into minutes. So in a nutshell, we have to convert the same units for both the metric day that we calculated and for the time of the duration for this particular question. So you could do it in minutes, you could do it in hours. Generally both will be fine. Okay, alright, so we're gonna move on to the next question. This is actually primarily a criterion D question. This is really about the tropics of Cancer and Capricorn. So we're looking at the different countries that is located on the Tropic of Capricorn, and the 17 countries that is located in the Tropic of Cancer in this case, and we'll be looking at comparing the life expectancy between the two tropics in this case. So obviously from this little visual you can see which countries lie in the Tropic of Cancer, and the same thing goes with the following part, where you could see the countries that's on the Tropic of Capricorn in this case, such as things like the Brazil, Paraguay, and so on. Now what this question does is that it did show some of the scattergraphs that shows the relationship between life expectancy and the other factors. So we this question generally is quite easy because you're supposed to just simply identify the correlation for each of the scatter graph. Now, so for the first one, obviously there isn't any relationship, so we're going to put this as none because the points are all scattered. This obviously the next one, this looks like there is a negative correlation, but it's not exactly the strongest, so we're just going to put this as negative. This one obviously, because the points generally follows a downward trend and the points are clustered together, so obviously they have a stronger relationship, so we're going to put this as strong, negative. And similarly goes for the next two examples. This is obviously a positive correlation because it's going in an upward trend, and this is a strong positive because of the points being clustered together, which is better than the previous one. Okay, so this generally should be quite easy. Then we got some data given to us for 2021 with the life expectancy of age in years for the Tropic of Capricorn. And this obviously goes into question 7b, where you're supposed to put in the numbers for the box and whisker plot. So the first line that we have here is the lower quartile, which is usually what we call Q1, which is the lower quartile. And let's just do a quick recap on how to find the lower quartile. We first need to find the median of this data. Now obviously we got 11 countries, so the median should always be the 6th position. So we're going to count 1, 2, 3, 4, 5, 6. So this guy is the median. So maybe I should put 71 right here because this line is basically the median. And of course this line is the upper quartile. Now, to find the lower quartile, you need to look at these 5 numbers that comes before the median, and we're going to find the median again. And ultimately, we just realized that this number is going to be the lower quartile. And again, looking at the on the other end of the spectrum here, we have 79, which is going to be the upper quartile for this. Okay, so we're going to put the numbers here to be 61, and this will be 79, and finally the last number should be the maximum, which is 85. Okay, and finally we have the mode, which is the number or the age that appears the most for these 11 countries, okay, in 2021. So the number that appears the most was 59, which appears twice, so we're going to put the mode to be 59 here. That's easy, 3 marks. And finally, we're going to find the following measures of dispersion, which is basically finding the range and the interquartile range. Now we know that the range is basically taking the maximum, subtract the minimum. So we're going to take 85, subtract 59, so that gives me 26 here. And of course the interquartile range is basically taking the upper quartile minus the lower quartile. Okay, so it'll be 79 minus 61, so that gives me 18. Okay, so that's 2 marks in the bag. 70 is a very interesting question because there was a news headline that's written as the life expectancy on the Tropic of Capricorn is higher than the life expectancy on the Tropic of Cancer. And the objective later is we have to comment on this statement, and are we able to find evidence to justify this statement based on the data that's given to us and some statistic that we need to analyze as well. So there is a graph here that shows you the life expectancy for both the Tropic of Capricorn and the Tropic of Cancer, and you could obviously see the trends of the life expectancy for these 2 tropics, and it's quite evident that the Tropic of Capricorn has a higher life expectancy commencing from 1950 that probably goes all the way up to like about 1990, and maybe after 1990 onwards, that's where the life expectancy starts to be lower than the Tropic of Cancer. So we will use that later to help us with some of the arguments that we're going to make for that statement or that headline that we see here. Then we got image 2 that's given to you as well, which is the box and whisker plot for life expectancy in 2021. So we obviously just found out the values for the Tropic of Capricorn. So I'm going to put these numbers here so that we can actually see the comparisons better. So this was 59, that was 61, 71. Okay, I'm going to put the numbers in, 61, 71, then we have 79 and 85, and this will be 85. Okay, I'm going to put the mode here that we just found out. I believe the mode was 59. Okay, and we could also find out what is the mean if we want to, because we do have the data here as well. So we could have taken all the numbers that we have here, basically adding up the numbers, and we will divide this by 11. So we could do that in this case. It's not required because it's not basically asked for in this case, but that's if you want to do it. You could obviously just find out the mean by just adding up all the ages and just divide this by 11. Okay, but since the question did not specifically ask us to do it, then I'm not going to actually do it as well, since to kind of save some time as well. So I think it's optional if you want to find the mean or not. Okay, so now this is the part that we need to spend a bit of time on, because this was, I believe this question was worth 10 marks. And the question is basically analyzing the data on life expectancy and comment on the deadline on the headline, and in your answer you should be identifying the elements relevant to your comparison. Then you will compare the measures of central tendency, which is things like your mean, mode, or median. The measures of dispersion, which is like your range and interquartile range. Then you will comment on the headline and you will justify the degree of accuracy of your results. So these are all very typically part of the criterion D task. Okay, so we're going to consider some of the real life elements first. There are several answers that are accepted in this question, so I'm just going to list out a few and you could find some that resonate with you the best. Okay, I think the first one, which is the most obvious, is could use the mean or the median or the mode. Okay, so again, it's basically up to you. I probably would choose more of the median and the mode because of the fact that those numbers generally are given to you, but of course you could also find the mean if you want to go about getting through the hassle of doing it. The second one that I think should be considered could be the range or the interquartile range, which is the measure of dispersion, which I believe you could have used this to your advantage as well. Of course you could look at the trend based on the graph over based on the graph here. You could have obviously just draw a line of best fit in this case, but I'm just saying the trend over the years should generally be good enough for this one. So trend over the years, I wouldn't even do the line of best fit personally for me, because it's not even asked to it did not ask me to do it in the previous part. So I don't think it's a good use of the time to do something that is not required at all. Okay, so we could use trend over the years, which was given to us. Of course you could use things like the upper quartile, the interquartile. I'm just going to write this here first: the max or the minimum, or you could use the lower quartile or the upper quartile. Again, it's entirely up to you, but technically you don't have to list them all out, but something that you think would be relevant to your comparison. But I think these are some of the very acceptable answers, and some that you probably would use very frequently as well. Okay, so we're going to start now looking at making the comparison. I'm not going to go through all the points here. I'm just going to obviously just choose the points which I think would be good. But generally what I think the first three should be the ones that you should be focusing on, because I think in option 4, using just the maximum or minimum is probably difficult to make any comparison or to make any significant conclusion from there. Okay, so let's look at the first one first. So I think we need to make a comparison, which means you have to compare those numbers as well. Okay, so that's why I say from the box plot, it is easy for us to compare the box plot from this. Okay, so I think what we could do is, if we compare these two box plots here, I think it's very obvious that the Capricorn has a higher median. It has a higher okay, maybe we should look at the range and the interquartile range as well. So I'm going to find out what is the range for Cancer. That would be 81 minus 59. That gives me 22. And the interquartile range is just going to be 76 minus 67. So that gives me 9. And earlier we have obviously found out what is the range and the interquartile range. It's obvious that Capricorn has a higher range and an interquartile range. So let me just put all this down in the same place. Okay, so range is was it 16? No, 26, sorry. And the interquartile range was 18. So generally the Capricorn has the higher numbers in this case. Okay, so we could just simply say that Capricorn has a larger median interquartile range and range. Okay, and you could also say that Cancer, obviously the mode is higher. Just to let you know, if you work out the mean for Capricorn, that's actually going to give me approximately about 69.9, which is about 70 years. Okay, so obviously it's less than Tropic of Cancer. So we know that Cancer generally has the higher mean and mode. So we can actually write this as another comparison as well. So Cancer has a larger mean and the mode. Okay, so that should give you some nice little points as well, to make those little comparisons. And it's important for us to show those values if you want to get any points. Okay, but if you want to get the full points for making any comparative calculations for this one, I think it is important for you to look at, because I'm just looking really very quickly at the mark scheme as well, is that you are supposed to compare the mean and also comparing one from the range and comparing one from the mode or the median as well. So if you can actually do that, you will get at least 4 marks for this particular part. So comparison is basically worth 4 marks for this. Okay, so it's not a difficult task, and all you need to do is just simply comparing the two numbers on why Capricorn has a larger median. And I think all this can be taken from the box plots here that we just talked about. Okay, but I'm not going to write it here because I don't really have a lot of space here, but you get the point. Okay, so this is worth 4 marks for the comparison. Now, and in terms of making any comments on this, there are obviously many possible ways to write. I'm just going to use a different color for this as well. I'm just going to use this, and so we could make a few comments here by looking at the trend over the years. Okay, I think that's important. Now we could obviously look at back at this little graph here, and we just talked about that the Tropic of Capricorn is obviously higher than the Tropic of Cancer from 1950 pretty much all the way up to 1990. Okay, so we can actually write this down. Capricorn has a higher life expectancy from 1950 to 1990. Okay, but it seems like this headline will not apply after 1990. Okay, but not after 1990. Okay, so I think this is one thing you could obviously write, but I think this should be complemented by the previous part on the comparison between the Capricorn and the Cancer Tropic. Okay, that should kind of give you like the full marks for this. So again, it's just using the graph trend and the comparison that you made in the previous part between the values of the measures of central tendency and the measures of dispersion as well. Okay, so for this is actually worth, the comment is just going to be worth 2 marks, I believe. Yes, it is. 4, 6. Yeah, that's right. So this is basically worth 2 marks. this is worth 4 marks, this is worth 2 marks, and finally the justification is worth 2 marks as well. Okay, so this is why it's worth 10 marks. And finally, I'm just going to talk very briefly about justifying the degree of accuracy of the results here. This is a very interesting question because it's more like a real life problem, and we want to look at how we can actually justify the degree of accuracy of our results here. Now, I think there's several possible reasons for this. Is that we could first imply whether the results that you have are inaccurate, or are they implied as being accurate in this case. Now, obviously, you would have to justify if you think that the results that you have are inaccurate. Now, I think there are many reasons to justify the inaccuracy of the results, because firstly, when we compare these two tropics in a way, we could basically say that both tropics have different number of countries. So it's basically comparing like 11 countries. Oops, sorry. Oops, what did I do here? Can we just erase this? Erase this? Okay, should be good. Oh, oh my goodness. Oh, what did I do? Okay, let's just get back to this. So just want to show you there are some clues that you can actually use for this question here. Okay, so if you read the earlier part, it says that there are 11 countries on the Tropic of Capricorn and 17 countries on the Tropic of Cancer. So when you have two tropics where they have different countries, we got an issue here, okay? Because the population, firstly, I think one thing you need to consider for this is that each country obviously do not have the same number of people. Okay, so that already created some trouble here. And I think another inaccuracy is typically the data that the number of people that we have in each country is not given. Alright, so I think that would be another problem in terms of the inaccuracy. Now, but of course, these are some of the more commonly real life factors that probably could be raised in this question. But I think there are many ways to look at whether the results are accurate or not. Okay, now I think some of you may consider as that the data is considered as inaccurate. I think the one that is which I felt which was the most interesting is that if you look at the image 1 graph, okay, which is the graph that's shown for the life expectancy over the years, I'm not sure if you realize that. Have you ever questioned where did the data come from the life expectancy in image 1? Was the average being graphed here? But if it's the average which is graphed here, we have no idea whether it's the mean, mode, or the median here. So we do have to question the accuracy of the result for this particular part. So I'm going to write this down first because I think it's a very valid point. I think we can say that it's inaccurate because image 1 does not show which average is graphed. Now, if this is only worth 2 marks, then I think just simply writing down one of the points will be good enough. Okay, you don't have to write that many reasons if it's worth 2 marks for this. So inaccurate because image 1 does not show which image is graphed. So you could explain that it did not show whether the mean or the median is used. Okay, so I think this would be a good one for the justification for this one. Okay, of course there are many possible other reasons as well. You could basically say that the life expectancies data, okay, was given to like if you look at some of the data here, like for the mean is given up to like 1 decimal place. But some other data is given to you like to the nearest whole number. So I think that is something that can be questioned as well. Okay, because maybe some of the expectancies, life expectancies, could have been rounded, but they were not rounded in to the common degree of accuracy here. So that could be something that could be raised as being inaccurate. There was one part in the mark scheme that says that it is accurate because you have compared both measures of the central tendency and the measure of dispersion. That generally could be fine as well, but I'm not very convinced about this answer, to be honest. I just feel like it's a bit of it's kind of like a lazy answer in a way. Alright, but generally I don't think it's that wrong. But I think there are more reasons to doubt that the results are more inaccurate because of the reasons that I just pointed out earlier. Okay, and again, if you want to use some real life factors, you could say that the number of countries in both the tropics are not the same. So again, if you're not comparing with the same number of countries, then somehow the data is not going to be very fair, and that will lead to some kind of inaccuracy as well. And I think I just mentioned as well, we do not really know the number of people that we have for each of the country. That could also create inaccuracies in the results. So this is probably connected to more real life factors in this case. So again, I would say for this question, you just need to choose one that resonates with you the best. Okay, but I think the one that I just pointed out are generally something that I think is perhaps the most reasonable in my opinion. But there is room for you to come up with different reasons for this. Okay, and that's why it's criterion D, and criterion D gives you a lot of room for autonomy in the answers as well. Okay, so I'm going to move on to question 8. This is a big question. It's worth 30 marks. And we know that criterion B, which happens to be the last question in the MYP assessment papers, that is something that you want to make sure that you spend time on practicing with the previous MYP E-Assessment papers, because they somewhat look very much the same, obviously in a different context, but the skills that's required are generally the same. But I just want to spend some time on this question, which is about a diagonal line that starts at a certain point A and reach point B, and you got another second diagonal line that starts at C and reaches point D. So you're going to have M and N to be the midpoint of these two line segments, and I will show you how this works out. Okay, so again, for stage 1, okay, you probably see a few points, which is B, D, M, and N, and these 4 coordinates are given to you. Now the main thing is that for each stage, this is the key point, is that B is going to move 1 unit to the right, and D is going to move two units to the right for each stage as the stage progresses as well. So if you look at, okay, so this is stage 1. Oops. Okay, this is stage 1. These are the points given to you. Now look at stage 2. Okay, so stage 2, the point has been moved to 1 step, and in D it has moved to 2 steps, so it becomes like 2 0 4 0. Then you could obviously find the coordinates of M and N, because remember, M and N is just simply the midpoint of AB, and N is the midpoint of CD. So generally this is how it goes. Alright, you have like stage 3, you have stage 4 all given to you, and the part of the question is basically asking if you could find the gradient of mn in stage 4. So the gradient of mn, so we have these 2 points here, which is 2, 5 and 4, 6, and we want to find the gradient. Okay, so I'm going to put 2, 5, 4, 6 here, and if you want to find the gradient, we know that the gradient formula is just simply y2 minus y1 over x2 minus x1. So I'm going to take 6 minus 5 divide by 4 minus 2, and that's just going to give me a half. Alright, and I just basically showed that the gradient is a half. Now question 8b, you probably would see like a little nice table here, and your job is to fill up the missing values all the way up to row 6. Now technically you should be able to spot a pattern, okay, even without looking at the previous parts. But the previous parts are important, right? Because this is the diagram that's given to you here somehow is going to lead back to the part where you will justify your general rule, but I'll come to that later. Okay, so please do not ignore these diagrams when you do criterion B investigations. Okay, but for now we should be able to fill in the numbers by spotting a pattern. If you look at the x coordinate, it's always going up by 0.5, so the next one is just going to be 2.5. The y coordinate remains as 5. This would be 3 and 5, right? And for n, you realize that the x coordinate is always going up by 1, so this becomes 5, and the y coordinate remains as 6. This will be 6 and 6. Now for the gradient, you realize that the numerator always is going to be 2, and the denominator is always adding 1 each time. So this will be 2 over 5. This will be 2 over 6. Okay. Yeah, so you should be able to spot this this little pattern here. Okay. There is no need for you to simplify 2 over 6. You can just leave it as 2 over the 6, because if you convert that into 1 over 3, that's where you're not going to spot any pattern anymore. So leave it as 2 over 6. So it says describe in words 2 patterns that you see in the table for the gradient. So I think we can just say that the numerator is always 2, and we can say that the denominator increases by 1. Okay, so I think that's 2 very obvious pattern. And we say write down a general of G in terms of n. So since the numerator is always going to be 2, so that means in the general rule your numerator needs to be 2, and since this number here is always going to be the same as the value of n here, so we're just going to put 2 over n as the general rule for this. Alright, so it's too bad, isn't it? It's like 2 marks, 2 marks, and you have 2 marks here, so that's 6 marks in the bag. Alright, so the next part, we're going to verify your general rule for G. So let's talk about this again. When it comes to verification, you want to be sure, right? And this is something that is really important in the e-assessment. Now, if you want to verify for the general rule, please make sure you use an example that is not given to you in the question now, because example 1 to 4, all the numbers are given to you, but examples 5 and 6, these were not given to you originally. So it is okay for you to use example 5 or above, okay, or anything larger than example 5. But I technically will go with the smallest one, so I'll tend to use n equal to 5 in this case to verify my general rule. Okay, so we want to do like when n equal to 5, we want to put this number here, which is in with the general rule which you found in the previous part. We know that this is going to be 2 over 5, but that's not good enough, because how do we know that this is actually going to be 2 over 5? So we need to go back to the table again. Okay, so we need to use like typically another way to find out why 2 over 5 is exactly the correct answer in a way. So we could just basically say that based on the table given to you, so we can just compare with the table, is that when n equal to 5, if you add 1 to the previous value, which is 2/4, okay, that will give me equal to 2/4 plus 1, which gives me 2/5. So basically you need to find both two ways that gives you these two answers here, and this answer came from n equal to 4, but you need to add 1 to 4 in order for you to get to n equal to 5 based on the pattern that you mentioned. So you have to write this when you verify your general rule. Okay, so you could use the table to help you with the verification process as well. Now let's look at question 8f. All right, and this is probably worth what, 3, 5, 7, 9. Yep, so this is 1 mark. So far we have done like 10 marks worth of questions, so the final part is going to be worth 20 marks, which makes up 30 marks for the last question. So again, we're going to be considering the length of mn and how it changes for each stage. Okay, so the question says investigate the values to find a relationship for the length L in terms of n. So you should predict more values, record this in the table, and find a pattern, and write the general rule, test and verify and justify. So it's a very common question for criterion B. So the same thing again is that if you look at the length of mn, alright, I'm just going to put all these numbers here first again. These numbers came from the previous table as well, but we want to find out some pattern with the length of mn. Now if you look at the denominator, it's always going to be 4. Alright, but if you look at the numerator, it started off with 5, then becomes 8, then becomes 13, becomes 20. So we do know that 5, 8, 13 and 20, this is adding 3, this is adding 5, this is adding 7. So we know that the next one is just going to be adding 9, and the last one is going to be adding 11. So this is going to be 29, and this is going to be 40. So this is going to be 29, and this is going to be 40 here. Okay, and this actually kind of reminds us of a nice little sequence, which is what we call the quadratic sequence, because the second difference is always going to be the same here. Okay, so that should help us with the first part of it. So it says describe in words, okay, a pattern for the length L in this case. So again, there's several patterns that we can actually write for this. I think one pattern that we could basically write would be with the numerator and okay, now what I think would be a good way to write a pattern for the length. Alright, some of you may be looking at just simply the numerator and looking at the denominator. Now, I don't think technically there's anything wrong with this, but I think, okay, I'm just gonna write this down first. Okay, so firstly, because technically I'm very excited usually when it comes to patterns like this, is to kind of find out what is the general rule, because when you find the general rule, it also describes the pattern here. But I think when you describe or you attempt to describe the pattern, it's going to give you some marks as well. So I'm going to say that the second difference for the numerator gonna be 2. Okay, I think I just talked about why the second difference is always gonna be 2. There are several rules that we can actually look at as well. Some of you may say that the difference between the numbers for the numerator is an odd number. Well, I mean, technically there's really nothing wrong with this as well. Now, because this part is going to be worth and we need to combine this with finding the general rule. So I'm just going to write down all the possible patterns first. So I could say the denominator is always 4. That's one possible, but it's a very simple pattern. Some of you might even write that the difference between the numbers, the difference between the numbers in the numerator is odd. Okay, so technically I don't think there's anything wrong with that. Okay, what I want to do is I should try to, let me see if I can just create a new page. I'm kind of running out of pages here. Let me see, how am I gonna do this here? Nope, it's not here. More tools, organize pages. Just gonna add one more page, blank page here. There we go. So here. Okay. Now let's come back to this. Okay, so done. So I got a new page here. Perfect. Now, so I'm gonna start having a go at finding the general rule. Oops. Fresh. Okay, I'm gonna have a go now at finding the general rule. So I'm going to start off by looking at the numerator, which is 5, 8, 13, 20, 29, and 40 here. Now we do know that the first difference is going to be 3, 5, 7, 9, and 11. But the second difference here is going to be 2, which is what I'm really am interested in this. So the second difference is 2. Now, we do know that if the second difference is always going to be the same, that's always going to lead to something what we call the quadratic sequence here, which means that the general rule is going to involve something what we call n squared. Okay, now we know that this is the first term, this is the second term, this is the third term, and so on. So if we have the second difference to be 2, there is a little trick for you to find out how we could make the general rule for this now. So a little tip for me, what you want to do is you want to take the second difference and you're going to divide this by 2 first. So this is actually going to give me 1, and this 1 is actually going to be your coefficient of n squared. And why do we have to call this n? Is because your job is to find out what is the general rule in terms of n, which is based on this little n here. So if we start off this with n squared, now remember we started off with the number which is 5, 8, 13, 20, 29, and 40. Now, if we start the formula with n squared, and we know that the first number is the first term, so if I put n to be 1, 1 squared is going to give me 1. Now, If I put n to be 2, which is the second term, 2 squared actually gives me 4. If I put n to be 3, this gives me like 3 squared. Then this will be 4 squared, which is 16. 5 squared will be 25, and 6 squared will be 36. Now, I want you to compare these two sets of numbers here. Now, this was what was given to you in the question. Now, these numbers came because of the fact that we started off the general rule with just simply n squared. So we know that, and you probably would have realized something, is that all these numbers that we have at the bottom row is always 4 less than this. So basically, if I want to get these numbers to be the same as what we have originally given to us in the question, which is these numbers here, all I need to do is I just need to add 4. I need to add 4. I need to add 4. And that's going to give me the numbers which is in the first row. So if I have the, and that typically gives me the general rule, which is basically n squared plus 4. Okay, so I think I just found myself a general rule. So L is basically the same thing as, but this is only for the numerator. Okay, if you look at the lengths, you have the numerator and the denominator and the square root sign. So I'll put the square root sign here. Numerator is n squared plus 4, and the denominator is just going to be 4. Okay, because the denominator here is always going to be 4 here. Okay, so that's going to be the general rule for this. Okay, so I do really need you to be able to find the general rule of a quadratic sequence. If you need any help on this, please let me know, and I'm happy to do a tutorial on this. Okay, so let's erase this now. And we're going to do the next part is we're going to start looking at testing and verifying the general rule here. Again, there are a few things that you need to take note of on what testing and verification means in the criterion B. So let's get down to business. Okay. Right. Oops. What is happening? Okay, sorry about that, some technical issues here. Okay, so let's go test the general rule. Now, when it comes to testing of the general rule, what you need to do is we can actually use the numbers given to us in the table. Okay, so you could choose any numbers which from 1 to 4, because 5 and 6 technically is not given to you, the length. So you could use either from n equal to 1 to n equal to 4 here. So this is what I would do. Okay, I could say that when n equal to 4, L is equal to 4 squared plus 4 divided by 4. So this will give me 16 plus 4 equal to 20. Sorry, equal to 4. So that will give me root 20 over 4 here. Okay, so that is one way to test it. Okay, and this should be the same value as the same value as the one given in the table. Okay, so this is what we call testing of a general rule. Now, so, and you need to verify as well. So it's the same thing we're going to do when n equal to 5. So you should be using the ones that's not given to you. So you could use 5 or 6 or more. But I think you should always do the one that's smaller. Okay, that makes your life so much easier as well. So when n equal to 5, we do the same thing again. We do with the formula. So you're going to get 29 over 4. So again, it's the same as the one given to you in the table. Okay, so that's one way you could obviously verify it. But it's also important, okay, to look at by saying that because this each time this is adding 3, this is basically adding 5, this is basically adding 7, and this would be just adding 9 to it. Okay, so again, if you want to make the verification process to be better, all you could say is that when the pattern to get from n equal to 4 to n equal to 5 is basically just taking 20 plus, we just talked about this, plus 9, that gives me 4 here, so that should give me 29 over 4. So these two values should somewhat look the same if you want to verify it. Okay, so like I always say, verification requires like 2 methods, and I think that's a very good rule of thumb when it comes to verifying of the general rule, just to be sure that you're actually getting the right rule. If you could prove it that these 2 ways actually leads to the same answer as well. So a few things again, I just want to summarize when it comes to testing is that please use the examples given to you in the question, while verification, please use only the ones where the values are not given to you, okay? But you always want to use like the smallest example. So in this case, because 4 examples have been given to you, so you want to use the next one, which is example 5. Okay, and finally we want to look at how we could justify the general rule, and that's going to be the one that's going to give you 4 marks if you're able to justify this whole entire general rule here. So I just want to show you that how can we prove this general rule, which is the same thing as how we can justify this rule as well. So I'll show you how we can do this. Now to get this formula, what we need to do is to make use of the diagram that was given to you at the beginning of this little investigation. Now this is basically finding the length of a line, and we know that to find the length of a line we need to consider going back to this again. Now let's go back to what we know of a length of a line. So I want to show you something first. Now we know that the length of a line, if you have 2 points here, let's say if we have this to be x1 and y1, this is x2 and y2. Now we know that in order for us to find the length of a line, so the length of a line, we know there is a formula for this, which is basically taking x1 minus x2 squared plus y1 minus y2 squared. Now this is something obviously you have learned to find the length of a line. Now I'm going to use the same idea to help us to find the length, but in this case, all right, we're going to start off by using n. Okay, now which means that I'm not going to set a number for n, because n obviously could be any number from 1 to 8 to 20, but I'm just going to call that number just simply n. Okay, now so what we want to do is we want to find out what is the coordinates of m in terms of n. Okay, now we do know that the y coordinate, irrespective of what n is always going to be 5, but we do know that the x coordinate is always going up by 0.5. So, and we do know that this number, which is the x coordinate, is always going to be half of the n value. Look at this, this is 1.5, this is 3. Do you realize that this is always half of this number? So I can actually put the x coordinate to be 0.5 n. Does that make sense? Alright, because the x coordinate is always going to be half of n, so I'm going to put that to be 0.5 n. You could have put it as half n if you want to. Now I'm going to do the same thing for the n coordinate in this case. Now the y coordinate is always going to be 6. Now, but you realize that the x coordinate is always going to be the same as n. So I'm going to call this n6. Okay, so what is the purpose of doing this? Now, if I know that m is 0.5n and 5, while n is basically n over 6 here. So I'm going to find out what is the length of mn by using this formula. Okay, so you can call this x1, you can call this x2 for m, for n, it doesn't really matter, okay? But just to make my calculations easier, I'm going to call this x1. Wait, let me choose a different color. I'll use this as x1, this will be y1, this will be x2, this will be y2. You could put x1 to be 0.5 n first, that is fine, okay? So what I'm going to do is I'm going to use the formula by doing n minus 0.5 n, you square it, plus I'm going to take 6 minus 5 and I'm going to square it. Now, so n minus 0.5, n is the same thing as 1n, so 1n minus 0.5, this is going to give me 0.5n, and I'm going to square this, and 6 minus 5 is 1, so this gives me 1 square. Now, if I simplify this, 0.5n and you square it means you take 0.5n multiplied by 0.5n, so that's going to give me 0.25 n squared, while 1 squared is just going to be 1. Now, the thing about this is that if you look at the original general rule that we came up with, it doesn't have a decimal, so I can actually convert 0.25 into a fraction. So I'm going to convert 0.25, which is a quarter, and I'm going to write it like that. Okay, now a quarter n squared is the same thing. Now a quarter n squared is the same thing as saying a quarter times n squared, and this is the same as saying a quarter times n squared over 1. And if I simplify this, this is going to give me n squared over 4. So that means I can rewrite this as n squared over 4 plus 1. But 1 can be written as a fraction as well, which is 1 over 1. Okay, and since the denominators are different, I can make both denominators to be the same. So this can be written as n squared over 4 plus 4 over 4. And if I simplify this, I just need to add the numerator together, and I put the denominator as 4. And that would look exactly the same as what we have here. Does that kind of make sense? And I think by doing this, we have simply justified the general rule. Okay, so yeah, this is it. It's a very long video, okay, but I hope this video gives you a rough sense on what you need to watch out for when you do your criterion B and criterion D question, which is the last two questions. They are very time consuming, so you need to make sure that you allocate enough time during the actual e-assessment for these questions, okay? Because they are worth a lot of marks, and some students, I believe, would even think about doing the last question first, because if it's worth 30 marks, then why not do the question that is worth the most marks first? Now, I think that's a good strategy, but for those who may not like criterion B investigation too much, then maybe you don't really want to start this question first, because it might just dampen your morale when you do an assessment of such high stakes as well. Okay, but do get some practice on criterion B investigations. Look at some of the other past papers. Generally they work very much the same. When it comes to testing, verifying, justifying, they all look very much the same. Sometimes they use quadratic sequence, sometimes they use like linear sequences. So if you are confident in being able to find the general rule for quadratic sequence, for linear sequences, you should do very well for criterion B. Okay, so this is it. If you have any questions, or if you need me to do any tutorials before the actual e-assessment, please let me know. Happy to make some last minute videos if you need that to help you with your revision. Okay, so hopefully you like this video, please subscribe to my channel. Please make sure you let this channel made known to your friends as well. And I'm just trying to build, just hoping that this video can reach out to as many people as possible, to help as many people as possible as well. So if you like this video, it is very long, it's very detailed, but at the same time, this is just coming from some of the experience that I have being an MYP teacher for such a long time. But hopefully this helps, and I'll see you guys very soon again. Alright, take care, and I'll see you soon. Alright.